Ah, yes, LeetCode. Don't we all just love it? Don't you worry. Today we're going to go through LeetCode Problem 1 and we're going to tackle it step by step together. And I'm hoping to make a series out of this, so stay tuned. Everyone, and welcome back to my channel. So today we are going to be solving the problem to sum in LeetCode. So my goal is to try to break this down into a step-by-step solution and walk through it as if I was doing this in an interview. So you guys can either follow along, or I will be talking to you as if you are the interviewer and explaining my thoughts, just so that we're all on the same page. So this problem is problem 1 of the LeetCode problems. And what I'm going to do here is read it. I'm going to explain my thought process afterwards. I might not write comments as thoroughly as I did in my Advent of Code challenge, which, if anyone's interested, I did solve a few of those for 2022, I believe. So if anyone's interested in the Advent of Code problems I solved, take a look over here. I'm going to put a link. Other than that, yeah, let's go ahead and dive right in. So given an array of nums, oh, I should start the timer before I start reading, because that's included in an interview. Given an array of nums and integer target, return indices of two numbers that they add up to the target. Okay, you may assume each input will have exactly one solution. Okay, great, so we can stop as soon as we find one. And you may not use the same element twice. You can return the answer in any order. Perfect. You need to return indices. Okay. So here's an example. You have nums. So each input would have exactly one solution. So there is no situation where there is no solution. And the follow-up is, can you do it in O of n squared time complexity? Well, we'll get to that later. Cool. So my immediate thought is a brute force solution, because you should always start with just getting something working and then iterate and refactor and get it looking nice to, for example, less than O of n squared time complexity afterwards. Because the worst case is if you spend a long time writing your brute force, you can at least tell your interviewer, hey, I was going to do this and I was going to refactor it, but this works. Okay, so the solution I'm thinking of is O of n squared. Essentially what we would do is we would loop through each index in the list. So for example, you go index 0, 1, 2, 3, 4 in a for loop. And if on your current number, so say I'm at 2, I would figure out what the remaining number is. So I take the target, subtract the current number, so 9 minus 2 is 7. And then in the rest of the list, so I'd remove the current element, or like split the list so that it's everything before and after the current number. And I'll try to find a 7. And then if I find a 7, yeah. So if I find a 7, I would just skip over the current index. If I find a 7, then I'd add it. That's the answer, and I'd add it to the output, or I'd set that as the output. So let's start with writing that out. So for index in range length of nums. So my current is nums at index. So remaining is I want target minus current. This, yeah, so the brute force again is like I would loop through it again. So for other index, yeah, because naming is the hardest part, in range length nums. So we want not our current number. So if other index does not equal current index, does not equal index, then if other number equals nums at other index, if other number equals remaining, return, that's it, we're done. Let's do index current, index other index. Okay, otherwise we just keep going. That's the wrong thing. We would do none, which we shouldn't ever hit this case technically. Now what I would do is step through it with the interviewer. Like I would take this case and I would verbally step through it. So let's do that. So we have 4 index. So we're going to start 0, 1, 2, 3, 4, whatever. So index in the range of the length of num. So until the end of this array, you're going to take your current number, which in this case would be 2. The remaining would be 9 minus 2, which is 7. And then for other index, so we would loop through this again from 0 to number. If other index does not equal index, so we would skip 2, it would not hit this condition, it would just keep looping. So we're at 7. So the index is 1, it does not equal this index, so we go into this. So other number is 7, and then if the number equals the remaining, which in this case they're right next to each other, so it does, so we're going to return the indices. So I would step through these as well, but I don't want to waste too much time, so I'm just going to run the case for now. It's slow. All right, we passed all the cases. So this is the brute force solution. It is O of n squared, because you can see here we're looping through, the first loop is O of n, and then within that we're looping through the whole list again, so it's O of n squared. We're pretty slow. What can we do to make this faster in terms of time complexity? Okay, so me as a person, I absolutely adore dictionaries because of the O of 1 lookup time. So for most problems like this, I always put everything into a dictionary. So what I could do is probably get this to O of n, and how I would do that is I'd loop through the whole array, and I'd put the key as the number. Oh, hold on, the baby's crying. Okay, we are back. The baby's on his playmat. You might hear some noises, like some jingles. So as I was talking about before, something I like to do to reduce time complexity is to use dictionaries or maps, depending on the language. So what I'm imagining here is that I could iterate through the list, like for the first time, and then for each index or each number, I will put the key as the number and then the value as the index. I will loop through each dictionary value, kind of the same logic as here. If I will find the remaining in the dictionary. Like I will check the current number, see if the remaining value is in the dictionary. If it is, then I will just get the value of that key, which is the index of that number, and return it like this. So that should lead to a runtime of O of n because we just iterate through the list once. Let's call this numsdict. This is just going to be empty for now. Okay, so we're going to iterate through our list, and then for each, okay, so we probably want to enumerate this just so we get both values. So value enumerate, I believe that's the syntax. And then we can probably check it as we go as well, like if it's already in there. Or no, let's keep it simple. Let's look at the dictionary. Load the dictionary first. So this, we don't need this anymore. Let's just get rid of all of this actually, or comment it out. So numsdict, the key is going to be the value, and then the thing is going to be the index. Okay, so we populate our dictionary just for fun. Let's run this. And obviously if this is a whiteboard interview, you wouldn't be able to do this. So, but let's see what happens. Run. Yeah, okay, cool. So that looks like what we want. So once we've populated the dictionary, we're going to go through, just going to loop through the dictionary here. So for key, just keep it simple. In numsdict, remaining equals target minus key. So let's say if remaining in numsdict, so if it is there, then we're going to return numsdict at key, and this is going to be like that. Numsdict at key, and we're going to do numsdict at remaining. Otherwise, we're going to return none. And then we're guaranteed to have this thing, so hopefully it works. Let's take a look. We don't need this anymore. Let's step through it again. We initialize the nums dictionary, and then we populate it with all of the numbers. So we have the key as the number itself, and then the index is the value, because what we want to look up by is like 2, 7, 11, because that's how we're going to do the calculation of target minus current number, and we want to look up that value in the dictionary. So that's how we're storing it. And then for key in numsdict, remaining equals target minus key, which is the same logic we were doing before, except we're flipping this now, where we say if the remaining, like the value is in the nums dictionary, then we return the indexes for both. Let's go ahead and run it. Wrong answer. All right, why is that? Let's debug this real quick. Oh, we're hitting our 15-minute mark. Let's do some debugging here. Case 1 worked. Oh, right, because putting the same value twice, right? But we can't do that, so we forgot to account for that case. Okay, so we need to make sure the index value in the dictionary is different. So how are we going to do that? I think I'm going to do this a little differently. So yeah, I know I'm past the 15-minute mark. There's a lot of context switching because I had to go and see the baby as well. So we're going to try to pivot here. I think we're going to make the values an array because there might be more than one. If value in numStick, like it's already there, numStick at value dot append. We're going to add the index. Otherwise, this is going to be an array or list. Okay, so that's a bit better. Now what we're going to do is, so I think actually what we could do is look for the remaining as we go. That way, like, we can shortcut this logic a little bit. I know it's duplicate logic. I would refactor this. And actually, another thing I would do is that I have, there's a data structure in Python and built-in called, or not a built-in, there is a library you can use called default_dict where you can initialize a dictionary with a specific type of value. So for example, you can initialize it so that when you add a value to the dictionary, it will initialize with that type all the time. Essentially, you wouldn't have to do, if I'm putting the value in for the first time, add it as an array, otherwise append it. You would be able to kind of do that in one line, but I don't remember the logic for that, initializing that off the top of my head right now. And considering this is an interview, I'm going to skip adding it and do it the long way. So for each index, we're going to check the key. If the remaining is in numDict, return, this is not going to be key, this is going to be value. So if the remaining is in numStick, return numStick. Okay, no, you want to return the current index. So we're shortcutting. And then numStick that remaining. Okay, so we should actually technically find it in here. So we don't need this. At some point, we will find the matching value. Otherwise, if we don't find it in the dictionary, then we're going to just like put it in. So that should stop some of that overlap case essentially. So let's run this. Wrong answer. Oh dear. We have the right thing. We're just nesting it. Or we should put the first one we found technically. Let's just swap them around. This isn't the issue. It's just me. Oh, right. Okay, that makes sense. We need to do the first value. Because it's a list now, right? So we want just the number. We don't want everything. There we go. Look at that. We passed. Okay. So I think that's the fastest I can get it. So right now, I'm sure there is probably a faster way, but in terms of just getting it to not be O of n squared and getting it to be O of n with the lookup times, I think that'll be better. And there we go. We hit 20 minutes. And for the sake of it, let's hit submit as well. Hopefully we're all good. There we go. Memory beats. Okay. Time taken 20 minutes. Oh, right. That's how long I took to solve the problem. Got it. I thought that was how long it took to run. So yeah, we were a bit over what I wanted. We're gonna attribute that to me explaining a bit more. So I hope you all learned something and I hope this was useful, and how I break down problems kind of gave some of you inspiration on how to tackle the problems going forward. Stay tuned because I'm gonna try and tackle other LeetCode problems going forward. I want to try to get through at least problems 1 to 50 because I feel like that covers a lot of the different types of problems and data structures you could encounter. So yeah, join me for the next video. If you want to see more stuff like this, where I tackle a problem and I break it down and I kind of write out all the steps and talk you through what I'm thinking and how I want to go about it, you can click here. You can click here, and I'm going to link my Advent of Code series that I did a couple of years ago. I kind of tackle problems the same way. I don't think my style has really changed. I just write it out a bit more. So hopefully you all find that useful. See you soon.